Hello, this is Dr. Mears. Today I'm doing is rate of change constant? This is going to be glued into your ISN. So let's follow along. You've seen these tables before. You've actually done posters on them, and you've shown me that the change of the x's are going to be constant and the change of the y's are going to be constant. But what happens if the change of the x isn't constant and the change of the y is also not constant? Can we still find a constant rate of change? And the answer is most definitely going to be yes. Let's see how you do it, and let's see what this looks like. So here we have our first example. We have our x's and y's, and I actually put in the little arrows for you here because this is what we're going to be doing to be finding the change. So we start with -3 and -1. From -3 to -1, we need to find the change. We do the second one and minus the first. So it's going to be -1 minus -3. -1 minus -3 is going to be +2. Then we're going to jump down. That one's done. Jump down to -1 all the way over to 3. So we're going to be doing 3 minus -1, and that's going to be 4. Now, automatically you think, 2, 4, that's not consistent. However, we're going to find out that when we put it as a ratio of change of y over change of x, we're going to come out to be common ratio. So let's keep moving on. Done of -1. 3 all the way to 6, so that's going to be 6 minus 3 equals 3, and now I bet you're starting to feel a little uncomfortable because you're like, ooh, 2, 4, 3. Let's get that one out of there. 6 going out to 7, so we're going to have 7 minus 6, and that's going to be 1. Wow, this really doesn't feel constant. Let's keep going over to the y's. -3 and -1, so we're going to take 1 minus -3, and that's going to give us 4. It's out. 1 to 9, we're going to do 9 minus 1. Remember, it's always the second minus the first. We're going to get 8 out. 15 minus 9, 6, and out. 17 minus 15, 2. So just by glance here, you probably would feel that this isn't going to have a constant rate of change. However, we have to make our ratio of the change in y over the change in x and then reduce it. This is what we've been doing. So let's see what happens when we do that with all of these. So we're going to first be taking, let's put my little colorful bookmark here. Do this side. There we go. First, we're going to be taking this 4 and this 2. The y value is 4, so we're going to do 4 divided by 2. Then let's take 8 and 4. So we're going to write 8 over 4. Then let's take the 6 and the 3. 6 divided by 3. Then let's take the 2 and the 1. 2 divided by 1. And now what we're going to do is reduce these. And we want to see, once we reduce these, are they all going to be equal? Let's find out. 4 divided by 2, we can reduce by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. 8 divided by 4, we can also be reduced to 2 over 1. 6 divided by 3, 2 over 1. And 2 over 1 is already reduced, 2 over 1. So we check, are these the same ratio? Are they all the same numbers? Yes. So here it is yes, we have a constant rate of change. Yay. And so that's how you fully find if the rate of change is constant. So don't become uncomfortable once you see these numbers are now different, because what you really have to do is put it through the ultimate test, make those ratios, and then determine once you reduce them if they're equal. I have 3 examples now. They have directions with them. The directions say determine if each table has a constant rate of change. We need to show our work. So what we're going to do for each table is show constant rate of change, if it's constant or not, and then if so, what is that constant ratio that keeps coming out? So for each one of these, you're going to have to do our subtraction just like we did. So from 10 to 15, 15 minus 10 is 5. That's out. 15 to 25, 25 minus 15 is 10. That's out. 30 minus 25, 5. That's out. And then the last one, 45 minus 30 is 15. And you do the same for the y's. 6 minus 2 is 4. 14 minus 6 is 8. 18 minus 14 is 4. And 30 minus 18 is 12. So let's write down these ratios. I'm sorry if there's not enough room here, but let's write down these ratios. Remember, it's always y divided by x, change of y divided by change of x. So we're going from here to here. So it's going to be, the first ratio is going to be 4 over 5. So let's write that down right here. 4 over 5. Actually, let me give myself a little bit more room. If you need more room, remember you can always tape this in your ISN and lift it up and do the work underneath of it. So let's write down 4 over 5. And then the next one is going to be, back up here, we got 4 over 5. 8 over 10. 8 over 10. The next one is going to be 4 over 5 again. 4 over 5. And the next one is going to be 12 over 15. 12 over 15. Now let's reduce them and see if they're equal. 4/5 already reduced. We want to check to see if that's equal. 8/10, let's reduce that by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. Looking good so far. 4/5, again, already reduced. Last one has to be equal, so hopefully it works. 12 and 15, let's reduce this by 3 and reduce that by 3. 12 divided by 3 is going to be 4. Woo! 15 divided by 3 is 5. We got a constant rate of change. So our rate of change here is going to be 4/5. Yes, it is constant. If constant, what's the ratio? Again, 4/5. If you feel like you're being redundant, that's good because that's what we're looking for. We're looking to see writing the same thing over and over. So that's going to be our first one. So this has a constant rate of change. Now I don't really have room I don't really have room here. So what I would do is, if this was in my ISN, I would just tape it down and then I would lift it up and I would do the work underneath. So here's an extra little piece of paper so that I could do my work. -12 and -8. I'm just going to be writing down the answers. I'm not going to be going through it. So if we divide subtract -8 minus -12, we're going to be getting +4. This also comes out to be +4. This also comes out to be +4, and this also comes out to be +4. Here we're going to get -2, -1, -1, and -2. When we make our ratios are going to come out to be -2 over 4, -1 over 4, -1 over 4, and -2 over 4. Let's reduce these. -2 over 4 equals -1/2. -1 over 4, you can't reduce, already reduced. Again, already reduced. This one, -1/2. Are these all equal? And the answer is no way that they are not equal. So let's slash that equal sign with a no. -1/2 is not equal to -1/4. Even though these are equal, does not make all of them. So it needs to look something like this, where they're all exactly the same. If you start getting reduced fractions that are not the same number, 2, 4, 4, 2, no, this cannot happen. So rate of change, we're going back and forth between, we have -1/2 as a rate of change, we have -1/4 as a rate of change, -1/4 again, and -1/2 again. So those are all of our different rates of change. And if they're different, that means it's not constant. So we can't even say that because there's no constant ratio. This one, from here we get -2, -2, -4, and -6. Here we get 5, 5, 10, 15. Our ratios are going to come out to be 5 over negative 2, 5 over negative 2, 10 over negative 4, and 15 over negative 6. 5 over negative 2 is already reduced. That does equal 5 over negative 2 again. Reduce 10 fourths, 5 over negative 2, sorry, 10 over negative 4. And reduce 15 over negative 6, 5 over negative 2. You guessed it, our rate of change are all 5 over negative 2. This is constant, so our ratio is 5 over negative 2. So this has been, is the rate of change constant? Hopefully once you finish, please glue this in your ISN or tape it in so that you can work underneath. I'll also suggest that in class. I hope this helped, and I will be talking to you shortly.